Hello YouTubers. In the last video we talked about the high-level architecture with a little bit of tooling around building an ASP.NET Core applications, the fundamentals and architecture of building ASP.NET Core applications. And like I said in the last video, you could use that mindset building any kind of software. Like if you're building mobile application with Xamarin, for instance, you could still break your application into brokers and services and controllers and views. You know, you could use models across all your applications. You could do the same thing with desktop applications. You could do whatever you want, you know, with that architecture. You may or may not, you know, interchangeably use the controllers if you're building an API and then you want to build a view for it. It's up to you. Some people like to build brokers, services, and then views, especially if you're building like a Blazor application or you're building a Xamarin mobile application or any other application out there. That's fine too. Controllers are just a dummy terminal, you know, that facilitates the communications between you and your views or your end users. I highly recommend always using controllers because controllers will be the final point of validation and, you know, making sure that before the request comes in, that the request is in good shape and is intact and you're returning the right errors and all that kind of stuff. Anyways, there's a lot to talk about when it comes to the fundamentals of building an ASP.NET Core application, regardless of whether you're working with version 2 or version 3. It doesn't matter what kind of software you're building. These fundamentals, I want you to focus on them and to know how to break out your application in a way that's easy to maintain and work with in the future. So let's go back to our high-level perspective here and talk about, you know, what our application really looks like. So remember how we talked about we have brokers, services, controllers, views, and we have models. And we broke out our services into the ones that contain the business logic, and brokers is the outside world communication. Controllers is the final point of contact before you branch out into views or APIs. That's all great, but I'm gonna run now with you into a scenario. We're gonna get in depth today around the first part of this architecture, and the more videos I create for this, we're gonna talk about, you know, the services and controllers and views and testing these and all that kind of stuff. But today we're focusing mainly on the brokers, the outside world liaison for your application, the class that handles the thin layer that you need to have to only communicate with the outside world and return whatever raw data that comes from the outside world. No more work needed. Once you stop putting business logic in your broker, know that you're doing something wrong. All right? As soon as you start doing if else, as soon as you start doing mapping, as soon as you start doing parsing, you're doing something wrong. All you need to do in your broker is simply communicate any errors with a try catch and just make a call to whatever service you're calling, whether it's a database or a notification or whatever. So today we're going to talk a little bit more about our brokers. Here's the application that we worked on last time. It's a very abstract application. Eventually, at the end of this series, I'm going to build you an end-to-end school application that adds new students and send a notification to the parents and all that kind of stuff. But for now, let's just work with our brokers. So let's say you have an ABC project, right? And this is an ASP.NET Core application with its test. Let's say you want to bring in an external library, right? Some external library. Let's call that library XYZ. It's an external, oh, sorry. Let's create a .NET Core library and let's call it XYZ, right? And this library is a client, a NuGet client, something from the outside world that, say, you know, sends a notification, right? So let's call it in here, notifications class, and it has some dummy method called send notification, right? And this guy here takes in a model class, and I'm gonna be very rough with the architecture here for that class because I don't care about it. It's just a random thing. Let's say notification, just takes a notification model and works with it, right? Just for kicks, let's say models, just for kicks, right? So this here is notifications service, a library that has a notifications service, and it takes in, it has a method that takes a notification object, right? Just a random library that I'm going to use to show you a point of view, right? Just a random library. It could be a SendGrid library, it could be whatever in the world, right? So we have this and we have that, right? Something that has a method and you need to send a notification. Great. Let's also add another model in here. And let's call our model notification response. And let's say this notification response is what this library is returning. Notification response, something like that. And it doesn't matter what it's really doing, so we'll just throw not implemented exception, whatever. New not implemented exception. All right, library. It has a method that persists, uses two models that are defined within that library. Great, right? Let's put, so that's the case here. The library that we have here is something that we want to use in our ABC application. So I'm going to go in here and add a new reference in the dependencies. I'm just going to add a new reference and I'm going to add XYZ library to my system, right? Let's rebuild the application real quick, see if we have any errors. It's not compatible. Why? Because this is 2.2 and I am running on 3 because I like to try different things. So here we go. Now let's build things. You want to make sure that all your projects are targeting the exact same version of .NET Core. I don't know about backward compatibility. You know, I haven't played around with that, but it's something that you definitely want to, you know, take a look at. So right, notification service. So I'm using this. So you're using an external library to go talk to something like SendGrid, right? So that means that you need a broker in here with an interface that's called IXYZ broker. Something that communicates with that service regardless what it is, right? And your XYZ broker, let's say it has a method in here, right? And that method says send notification. Now here comes the dilemma, the problem. The problem here is that if you have a hard dependency on your library's models and all your services are feeding off of that model, it becomes a problem. Because once you switch that library, now you're in this little dilemma of having to go and modify all the services that feed off of your broker, right? I'm going to show you that right now. We have notification response. Let's say you defined notification response, something like that. Let's say you defined your models based on the library that you're using, right? So you have notification. Here you go, notification. So I pulled in notification response, and that's your broker, and you went and implemented your broker here with a class, and you said this is my broker, XYZ broker, like that. An XYZ broker implements IXYZ broker. If you do control period, it will take care of that. Also do control period to clean up the unnecessary usings and make sure that your lines are not over 120 characters, so it's easy for people based on their views to read the entire line without having to go like this. You know, right now it's doing that because I'm zooming in for the video, people watching on mobile, but in the real world it looks like this, which means People don't have to scroll right and left. Once people start scrolling right and left, then your code is too long, right? All right, so you built a broker, and this broker basically, let's say, has a dependency on this library. So in your CTOR, if you do CTOR and double tap with, you just do double tap, and let's define a private read-only member in here, and let's call it XYZ service, right? If I know how to type service like that. Let's see, did I call it XYZ service? Oh, notification service, sorry. Notification service, right? And then this is your notification service right here, and you have instantiated your notification service in your broker. Something like this, right? And in your implementation, notice that I'm not writing any tests because your broker should be just a thin line that makes a communication to the outside world. I couldn't care less about you testing that. It doesn't matter to me, not a bit, because that should be covered within your acceptance and your integration tests. So you shouldn't worry about that for this particular layer. The layer that you want to care about when you're writing tests are for the services. All right, let's go back here and say this dot notification service dot send notification, and you are using the same exact models. So you could basically pass in that stuff and everything is good and dandy, right? It looks good. It looks good, right? All right, so that means if I have service A, let's build an interface for IA service, iService A. I like to end that, okay, IA service that uses some sort of programming to utilize that notification model that you have. And let's say you have an IB service, something like that. IB service. An IB service is also public. I don't know why it doesn't create it public by default. Honestly, don't know, but there might be a trick for it, not sure. And then let's say that your IA service and IB service does some stuff, okay? So let's say this is void do stuff A, no implementation here, and there is do stuff B. All of this is great and theoretical, but I'm going to show you now how terrible it is if you don't follow a particular structure, right, when you're building your application. So you have iService A and iService B. Let's go ahead and write an implementation for both of these. Just a basic implementation that has a strong dependency on the IXYZ broker. So let's go in here and say service A service, and A service implement IA service. And if you do control period, it will does an implementation for you like this, which is awesome. Someone might ask me, you know, when this is popping up like this, how come it's asking you to do implicit implement interface explicitly or implement interface explicitly? What's the trick here? What's the deal here? I'll show you the deal. If you do something like this, and if you go and do, if you're implementing multiple interfaces, and I'm going here on a tangent, but this is important. If you're implementing multiple interfaces, it's a best practice that you say, if you do this, if you do just implement interfaces, it'll work kind of, but you don't know which method is implementing which interface. It's kind of confusing, right? But instead, if you do this explicitly, now it's very obvious. Oh, sorry, this guy here. Now it's very obvious which interface are you targeting with your implementation. Especially if two interfaces had the same method name. Then now it's definitely definitely important for you that use explicit implementation of the interface. All right. So let's go back to our work here. So you have a service, and a service implements a service, and I'm not putting any implementation yet. I'm just going to write some tests. I'm going to show you how crazy things could be, you know, if you do them the other way. It's very important to learn this about brokers, and that's really what I care about for you to learn today. So all right, if you type in ctor and tap, and then you say private read-only IXYZ broker. So here's the first dependency, right? And then you have an input parameter, which is IXYZ broker. Like this. And then you're passing XYZ broker like that. It's all good and dandy, right? And then we're just verifying that in XYZ broker, you're passing in the right stuff, right? So in the same thing I'm going to do with the B service. I'm just going to go here and create a class, call it B service. Here's B service, and then there's IB service. And then we don't have multiple interfaces here, so we're doing the same thing. I could just copy that from A service like this. Go to B service, paste that in here, pull in the references, all good and dandy. And then instead of B service, you're doing A service, you're doing B service. So we have two services, no implementations, strong hard dependency on the IXYZ broker, right? That might look clean, right? Let's go write some tests. So in our tests, we're breaking things by services. Let's go here and say class. Let's call it a service tests. Follow the pattern, follow the exact same pattern. So easy for you to do things. And then here's another service. B service tests. The exact same thing, public. Right, and then let's add in, we're using XUnit in here, so it uses fact. And then let's do public void should call XYZ service broker. Right, so you're calling XYZ broker, you're breaking your test into a given, when, then, like we talked before, you're setting up your variables, you're running the execution, and then the then is where you verify things have happened, right? So let's create a mock. So XYZ broker mock equal new mock IXYZ broker. Go. Here's our broker, and then let's use the notification response to work with that stuff, right? So that we know that the call notification returns a response. The XYZ broker here returns a notification response, and we have a notification in here, right? So all right, so let's do that. So we have notification. Oops. Let's pull that guy in. And then notification. So we're creating a sample response, right? So okay, notification, and then let's create from new dynamics dot object filler. So let's say object filler, new object. Actually, it's just filler, and then notification. And then we could say create like that. This is not working because we didn't bring in the references. Again, control period. We'll bring in the filler reference, which is the dynamics object filler. All right, we have that. We created a notification. Now we want to create a response as well. So notification response using XYZ. Here's a notification response. New filler notification response dot create. See, the line is getting way too long. A good way to break the line is at the identification part, you could just break it like this. So now your code is readable. If your code, if your line is if your statement or one statement is taking more than one line, separate it with one empty line like that. So now you're reading this guy, and now this guy as its own individual thing. So very smaller things that makes your code, very small things that make your code really readable and easy to understand. It's so easy to write a code the machine that can understand, but it's very hard to write code that people can understand. And people is who we are targeting by writing this code. The machine already knows how to read binary. All right, so we created a response, we created a notification. Now let's set up the mock. So XYZ broker dot setup broker mock. Oh, XYZ, okay. XYZ broker mock dot setup, and then we're saying broker dot send notification, and we're giving it the notification that we have, and we're saying returns notification response, something like this, right? Very strong dependency on the broker. Now the when part. Before I change my when part, let's have even a stronger dependency by having the I service takes in a notification as a response in here, like that, like this. Response, and let's do the same thing to this guy. Let's have this guy also take a notification as a strong dependency, so we can pass that in here. Which means that the implementation for these services will change a bit, a tiny bit. We're saying notification. I'm going to tell you why I'm going to do that right now. It's a lot easier to prove a point. Notification. There you go. All right, you have two services. You have dependencies. You're passing in a notification that comes in from XYZ, which is this external library. All right. Now, back to our service tests. This is B service test. So you have that, you have XYZ. Now let's define B service, which is new B service, like this, that takes in the XYZ broker mock.object as an input parameter, and then B service will do a call B service dot do stuff B that takes in notification as an input parameter, and then we want to verify that our project here is doing what we expect. So since it's a side effect, it's returning a void. It's not returning anything. You want to verify that something was called X number of times, right? In this particular case, you're calling one time. So we could go here and say verify, so XYZ broker mock dot verify. Here's a broker dot send notification with this particular notification was called once. Now this thing is getting a little bigger, so let's break it down a tiny bit. Let's break the entire predicate like this, and let's get another line and say times dot once. So this is a lot cleaner to read, right? Two parameters, perfect. Now if you do Control RT, things should blow up. Technically things should blow up. Not implemented exception, right? Which means now that I am test driven, I need to go here and say this dot XYZ broker dot send notification, and I'm passing in the notification. All done and done, right? And then maybe you'll take that notification and do something else with it. The more dependencies you're having coming out of that, right? The exact same thing is happening with a service, I'm just literally going to copy the exact same code and do the exact same thing in here. The only difference is that I'm going to change from B service to A service. If you change the name and do control period, it'll change all the references for that. I don't know why I didn't change. I think it changed that across the entire file, which is not what I wanted it to do. Alright, let's say A service in here. And let's just bring our dependencies. So this guy, and actually I could just go here and just copy all of this. That would make life easier, right? And this is do stuff A, right? Same thing. If I run this, it should fail. Not implemented exception. Go down here, say this.xyz broker dot send notification, notification, done. Go back to your test, control minus, and then do control RT. It'll fail, it'll pass because it's calling the library one time, right? So if you look at what we did on a map, I wonder if I can show you the map here. You're gonna love this. Analyze. Yeah, they used to have something like a code map in here. I'm not sure if that's available anymore. Anyways, the point is, we have, if you look from a mapping perspective, we have how we implemented things. Things look something very similar to this. You build service A and service B, or service 1, service 2, and service N, whatever how many services. And all these services are adhering directly to your broker, right? This is a terrible pattern. Why is that? If I go here and decide to change my service, let's go here and build a new library. Let's say these guys built a new library that has features that we need, right? So I'm going to build a new library in here. And let's call that library modern shiny XYZ. So this is the shiny new XYZ library. And this library has its own classes and models and notifications, right? And this shiny one new library has its own models, its own implementations. Good software engineers extend their existing model, right? They don't add to it. Like when you make a new version, if they're doing XYZ, you know what, let's do it the way people would do it, you know, in the real world. If you go here and you create a new library, a new project, and then you say, I want to build a library, library. It's naive to think that people will give you a library that has a backwards compatibility. Not going to happen. So this is V2. So people built a V2, and I'm just going to copy literally the exact same things in here, but they're all V2. It's a new version of the same library, right? Why it's not letting me copy that stuff? That's weird. I'm just going to paste that stuff in here. Literally the same exact things. Copy, paste. The only difference is that these people just extended their existing work. The people that I have dependency on their code, right? So let's throw that away. Let's go to notifications, XYZ V2. That's your new model, right? And this V2. That's how people extend stuff, or they should. And this is also, let's call that V2. And this will be V2 as well. And this will be V2. I had a debate with myself before I did this, whether I should have these libraries ready before I start the demo or not, but I want to show you everything in action for a very specific purpose. V2, V2, everything is V2 now. A new version of everything, right? All right, notification, V2, everything is V2. Beautiful, right? And they handle to each other. All right. So these folks, the XYZ company that I'm relying on their service, have upgraded their versions, and I need the functionality that they're providing, and they don't have backwards compatibility, and I have to upgrade, right? Now watch this. If I go and say, I don't want any dependencies on XYZ, I want to upgrade to XYZ V2 and add this library in here and make sure that my library targets 2.2 because we've been burned by that before. If I try and build my application, your code will fail, your services will fail, your entire world will be technically on fire. Why? Because your dependencies here have changed. Now you're in this stage where things are unstable. If you have 20 services feeding off of that broker in a monolithic application, God forbid you build a monolithic application for whatever reason out there, what's going to happen is that you're going to have to fix a lot of code. And I don't care how fast you are under your IDE, there's still a lot of work, internal work that might have dependencies on your work, and it's just a big, huge mess, right? This here is this model. Brokers communicating directly with services. So what's the right thing to do? The right thing to do is to go do something like this. If it switches, why it's not going, let's see. Oh, there it is. Weird. This is the right thing to do. The right thing to do is for every broker that you're building, build an abstract layer in front of it. That would be a service that maps the business logic, that maps the models that your existing broker is returning to a local model that all your services could subscribe to. And now you have to only change in one place what's happening. You have only one place to change what's happening. And I'm gonna show you now how that works. So in the real world, you want to go to your models and say, I have this thing called ABC notification, and I have this other thing called ABC notification response. Something like that. Right? And your notification response will have, let's give these guys some properties so I could just show you really in action what's happening. Let's say it's, regardless, some ID, some response. I really don't care about the properties. Let's just give them something to show you how everything happens with a good architecture and good practices, right? And let's give the exact same properties to everything, to all the libraries that we have. Let's say they should be an exact copy of whatever libraries that you have. So notification, you have notification response, right? And then you have this service. I don't care about this service. It's just a dummy thing. The same thing with XYZ. Let's just add some properties to it. So I'm going to show you the mapping, how the mapping works. All right, great. So we built an XYZ service. So what is the thing that I built? Oh, we built two models, the ABC notification and the ABC notification response. Now we want to put in front of that XYZ broker an abstract layer. And that abstract layer will keep things away from its consumer. So I'm gonna go here and create a new interface. I'm gonna call it excuse me, ABC I don't know, XYZ service. IXYZ service. So that's the service that lives in front of this broker. Public. But the difference is that this XYZ service, because it's abstracting that work, it's returning actually the ABC notification response and it's using the exact same library, send notification, and it's using ABC notification. So it's abstracting away the external models that are coming from the outside world and converting them into a new model. Great. Let's build the concrete class of this version. So it's XYZ service. XYZ is what's coming from the outside world. An XYZ service is implementing IXYZ service. Here's the implementation. And also, it has a dependency, private read-only XYZ broker. So it's that glue between your actual business logic and the outside world. Here's a CTOR, IXYZ broker, XYZ broker, this.xyz broker equal XYZ broker. All right. Let's write some tests for that guy. So what this guy is supposed to do is supposed to do some mapping, and it's supposed to communicate with the outside world, and then whatever the outside world returns, it'll do another mapping for the response, right? So here's our expectation. Let's write a test in here, class, and let's call it XYZ service tests, something like this. XYZ service tests has a fact, it's an X unit, public void should call XYZ broker to send notification, something like that. So what are we building here? We're building the existing service. We have a given, we have a when, we have a then, and we're trying to build our dependencies just like the last time we did this. So var what is it, XYZ broker mock equal new mock I XYZ broker. Here's our dependency injection work. Let's pull in here all our dependencies. All right, and let's build some stuff. So we need to build a couple of things here. We could do GUID notification ID, right? And then just new up a new GUID in here. And we could have another GUID, which is notification response ID. Say GUID, new GUID, great. And then we could create a bunch of things. These are like our variables that we set up in the given section, right? So what do we want to set up here? First of all, I want to set up var notification. What's incoming? So new notification. This is the XYZ service notification. V2, since we're using V2, right? V2. There you go. And V2 has an ID. And this ID is the notification ID, right? The second thing, this is the outside world first. Notification response, new notification response V2, right? And this notification response has an ID, which is notification response ID done. So this is the outside, what's incoming, right? What we're converting to, right? Sending in, converting out. Now, our expectation, expected notification to be passed in, which is going to be new ABC notification. Your internal models that you rely on to communicate with your internal services, right? So that'll be notification ID. Again, the same thing, var expected notification response, ABC notification response, ID, notification response ID. All right, so outside world, internal models, all good and dandy. And now we want to set up things. So we want to go and say the verify the XYZ broker mock setup. First, we want to set up that guy, broker. Here's our broker dot send notification. So we're saying that this broker should receive a notification that looks as follow. It is of type notification v2, right? It's of type notification v2, and the notification, it's a little bit too big here. Let's break that down. The notification dot ID equals notification ID. I don't even know if I need the actual notification object. I think we're good, right? So I'm saying that, and this guy should return. So are we send notification? Okay, and then we're closing here and we're saying this guy send notification. Let's see, what am I missing? The type namespace notification response could not be found. Let's see, notification response XYZ broker mock. What does my interface all right. My interface is still using the older version, right? So v2, all good. Let's go back. So this guy returns what? This guy should return the actual notification response. So we verified that part. Excuse me. So we're saying when you receive something with this ID, return the notification response, which means we probably don't need that guy. We'll get there, right? So that means when I have my XYZ service equal new ABC service. No, it is XYZ service. New XYZ service. Let's see if I can pull that. Yeah. And this XYZ service takes the XYZ broker as an input parameter for dependency injection. Now here comes the fun part. The notification, the ABC notification response, actual response. That's what's coming from the service. So XYZ service dot send notification, and we're passing in the ABC notification, which is this guy, expected notification or input notification. So I'm passing in the input notification and extract that ID. We're mocking here based on the ID because this mocking system, if it's not the exact same reference, it won't work. So you have to verify it's the exact ID, right? And you have to verify it's the exact ID. Some people just say it is any object of this type. That's not good testing. That's cutting corners. Don't do that. Verify that you're passing the exact object that's actually coming in. All right, so we have an actual response, and then what we want to verify at the end is a couple of things. We want to say, verify that the actual response should be, this is where we're using the fluent assertions, should be equivalent to the expected notification response, which is this guy. So you can see here there's a little bit of mapping happening between the two, right? If I run that test now, everything will fall apart. Not just because there's a problem in the implementation, but there's a problem in the services that have very hard dependency on the previous library. So you see how things get complicated so fast. So I'm just going to comment this world for a second. I'm going to comment this whole world for a second, this bad previous implementation. I'm going to comment all of that. We don't need that for now. Here, comment all that world, reverse everything, right? And so are the tests as well. If you have the A service test, all of that, we're going to comment it, and I'm going to show you now how to do it the right way. So all of this is commented. Can I build? Let's see if I can build. Let's see, what are we missing? The actual implementation now. The actual implementation needs to rely on the new versions of things. V2, V2. All right, this is great. Let's rebuild everything. It should build. Perfect. Right, so we built this. Now, if I go back to my tests, we'll get back to the test that we commented. So this is XYZ service test. Now, if I run my tests, it's a little bit too, let's pull that guy in here. Control RT. Not implemented exception. All right, let's make an implementation. First of all, you want to have a private method in here that says return an ABC notification response, convert or map to, either way, map to notification, map to ABC notification response. And it takes in an input parameter of XYZ. What is it? What did we call it? Notification response V2. So this is the outside world. Let's break that guy down. If your method gets too long, start breaking on the parameter level. And what this guy does really, it just says return new notification response, ABC notification response with its ID set up to the notification response v2.id. That's all it's doing. Now in the real world, you're mapping a lot more than that. You're mapping much more parameters than that, right? The same thing is going to happen with the input parameter, right? So you have ABC notification, and you're saying map to ABC notification. And then we're passing in a no, you wanna map it to external notification, right? You wanna map it to XYZ notification. So you're taking in an ABC notification and you're mapping to XYZ notification. I think it's just called notification V2. Something like that. So your input parameter is ABC notification. And you're saying return new notification V2, and the ID is basically the ID, so it's ABC notification.id. Alright, so you have two mappers in here. Great. So that means that in here in the implementation, you want to say var notification equal map to XYZ notification. You're taking in the ABC notification and you're mapping it to that, and then var notification response v2, let's call that v2. Notification response, and then you have to map to ABC. This is the outside world notification response. You want to go and say this.xyzbroker.send notification, and you're passing in notification v2. Right, and then you're coming down here and you're saying return map to ABC notification response, which is whatever response you're having in here. So you see what I did here? I built two mappers for the input and the response. Two mappers for the input and the response. And I'm taking in a local input, converting into external input, and passing in the external input in here, and then taking that external output and converting it to internal output. That's so complicated. How do I explain this simply? How do I simplify this? You're building your local models, and anything that goes to the outside world, you want to make sure it converts to external outside world models. And when they come back, you convert them back into your inside world model, which is basically what this map is doing. Anything coming from here to the outside, this service is responsible for converting it into something the outside world would understand. Anything coming from the outside world, this one service here is responsible for converting it into something your inside world could understand. So when this guy gets updated or changed, you have to only change one class instead of X number of classes. It's called abstraction. It's what you do when you build brokers, right? So let's continue with our work here. Does that mean our test is passing? Let's find out. So if I go here and say Control RT, technically, in theory, it should pass. Historically speaking, tests haven't been passing for the first time. I'd be happy if they do. Did it pass? It passed. Fantastic. XYZ service test. You did do what I expected it to do. Alright, so you built your mappers. Now, all the services that you had that had hard dependencies on the broker, you shouldn't do that anymore. You only have hard dependencies on your own local models, which means this is your ABC notification. You're going to see how the world is a lot easier because I'm going to go back and convert back to the other library again. You're going to love how things look like when I convert things back to the other library. So let's do this. What do I have here? The iService, you're taking here a ABC notification, right? And instead of the iXYZ broker, you have iXYZ service, right? And this is XYZ service. The same thing in here, iXYZ service. And then you're using that basically to say this.xyz service and this.xyz service, like that. You don't need XYZ. You have no dependency on that external library anymore. iXYZ service, which means that your call here is directed towards this. But because we're following best practices, I'm going to throw that away and say throw new not implemented exception. Because I'm going to fix my test now. So that means if I go down here to my tests, a service, and I uncomment this guy, now I have no hard dependency on any external libraries within my business logic. You want to protect your business logic to make sure that it doesn't have any strong hard dependencies on anything on the outside world. Technically, every notification should be just ABC notification. And everything should just work the same. ABC notification, ABC notification response. Just a second. ABC notification response, and we have no hard dependency on the broker either, so it's XYZ service mock. Service mock control, and then let me do that. That's fine here. So now this is a service to service dependency, and that's totally okay. Which means that if I run this test now, it should fail, and then I get to write the implementation and it'll just work, right? Not implemented exception, go here, go back to this. Now we're using the service, control minus, go back to where you were in the code before, run your tests. Things are much better now. Look at your test explorer, things are passing. Right, let's do the same thing with B service test. So I'm just gonna copy this guy. B service test, uncomment the world, take these guys away, and do something like that. Should call XYZ service, send notification. You want to make sure you are using best naming conventions, you're doing the right stuff. Alright, since this is B service, so it's B service, and this is B service, like that, and B service, and do stuff B. Did I miss anything? B service doesn't exist because B service is commented. Let's undo that. So B service is going to be exactly the same as A service. I'm just literally gonna copy most of this stuff except for the implementation. I will not put the implementation there until the same thing for the interface as well. This guy has a dependency now on ABC notification. Boom. And this is your B service. You don't want that guy. ABC notification. This is B service, not A service. And this is the XYZ service. Fantastic. So that means if you run your test, you put the test first. So this is B service test. You put your test, you do control RT, everything. So now we have fixed the solution from a bad state where it has hard dependencies on external libraries into a hard dependency on an abstract layer that we could change whenever we want. Fantastic. So that means all our tests are passing. Everything is green. Fantastic. Now, if the same scenario happens at any time in the future, and let's say there is a V3 or we want to go back to V1, how much things do we have to change in this model to make things work for us? The only thing that we have to change is this guy. Maybe this guy. Or if we were to build a new broker, it'll just communicate directly with this guy. And you just have to fix your mapping. So one class that you're going to have to change in order for everything else to work out. I will not, and I'm going to do it that right now. The idea here is that I do not need to touch my business logic code if I change an external library that I'm using. Everything just should confirm automatically, unless there's something that is business logic related that you need an external library for, then you just need to update that abstract layer that you have here in the middle, right? So how does that work in the real world? Let's go back and say, okay, XYZ broker, we are going to completely remove, see that the goal here is that I don't touch my services. So if you see me going into the services code, then this is when you know this whole 1 hour video have failed, right? The idea that I'm trying to build for you have failed. So let's see. Well, I'm gonna go here in the dependencies. I'm gonna say I don't want the XYZ V2 version. I'm gonna use XYZ V1, which means things are gonna start to break, obviously, right? So you're changing your broker and your service. There's nothing else that needs to change, right? So that means that this guy will go back to XYZ, this guy will go back to XYZ, and all of that stuff will go back to its original state, including the broker with its implementation. Here we go. Let's see if I touch the services in any way, shape, or form. The ideal case here is that my services should stay completely intact, and their test should pass after I do that upgrade. So the broker, so I just fixed the broker, and the only other thing I need to fix is the abstraction layer, which is the XYZ service. Not even the XYZ service, some of the implementation of the XYZ service, which is if I go to XYZ service, I don't need this, I don't need this. We're back to the original state. This guy takes in a parameter that's this guy, and this guy takes in a parameter that's this guy. See how smooth and sweet the way how we are. Okay, here's a good point before I move forward with this. If the right side of your code is not clear what it's doing, it's nice to use the actual type. I know this saved us a lot of fixing in here because you're using the var, but from a readability standpoint, you really want to use just notification and be very explicit about the type that you're using. All right, the same thing goes here. It's notification response. Something like this. Line is too long, break it down. Let's call this V1 so we don't mix the here V1. Right, so this now is a much better. Now the type is clear. We know what's coming back from this guy. Your code is as clean as it could be. Now, the one thing we want to change now for the XYZ service is a test. Let's go back to the service test and let's just fix that stuff to notification and notification response and notification and take the V2. So have you noticed here, technically, if I click hit run, everything should still pass without me touching my business logic, the core of my work. This should still be intact. Is that the case? Let's see. I'm going to run. Everything passed. Everything passed. And that's the model that I'm telling you about. It could save you if you're if you're working in a monolithic application. This model versus this model. Why it's not switching? Let's see. This model versus this model is like heaven and earth, because you have to change in 3 places versus changing in 1 place. Okay, if you're changing the broker, then you're changing all these files versus changing just a couple of files. So in this case here, you're changing 1, 2, 3, 4 files. It could be 5, 6, depends on what your in is. In our case here, we changed 3 files. We changed the broker, we changed the service, we changed the service A and the service B. In the good practice case, we changed only 2 files instead of 3 files. And the more files you have, the more you see how obvious this is. Now, someone might ask me, says, what if I have only 1 place where I'm using that broker? Then it might be okay. It might be. It might be. But I highly recommend that you keep that abstraction even if your code is just calling just the one service. Keep that level of abstraction. It'll help you a lot in the long run when you're working with, because your application, if it's successful, is going to grow. And you should build your application in a way that is extendable, right? Even if it's a little application, a lot of the little applications that I have seen in the biggest corporates out there end up being ginormous applications, but they're very hard to maintain because people said, oh, it's just a little app. We don't know if it's going to grow or not. So make best practices a second nature for your habit, a habit that you follow second nature, no matter how small the projects you're working on is. If you know it's going to production, then build it right. If you're building a prototype and they tell you, oh, we need to go to production, then completely delete the prototype and rebuild it from scratch directly. James Gosling, the guy who created the Java programming language, said, no, prototypes is to completely destroy and rewrite from scratch. A lot of people don't understand that. They say it works. Why do you have to rewrite it? Because it's not maintainable. It's not in a good state, right? So today we talked about brokers. We focused on brokers with a little hint of services. We built an abstract layer between the brokers and services. We made sure that your outside world and your core business logic is completely separate and they have no hard dependencies on each other. In the next video, when we talk about fundamentals of building ASP.NET Core applications, we're going to talk about services. Everything you could think of when we talk about services, interacting with these services, what they do, and all the little, intricacies when it comes to, what makes a service, how much logic in a service, how you break your services into multiple services, all that kind of stuff. And then eventually at the end of this series, I'm going to build you an end-to-end application, like I said, that shows you how to build things from scratch, end to end. And I'm going to go show you all the cool stuff that you could leverage when you're building an ASP.NET Core application that makes the application maintainable and easy to read and easy to maintain. If you have any questions, comments, or concerns, please feel free to drop me a comment in the comment section. Follow up with this series if you're interested. It'll make your code really stand out, and you'll make your projects really easy to read and maintain and extend. And I couldn't thank you enough for watching, for the people following my channel. And don't forget to like and subscribe. And I'll see you in the next video.